So Mesh is a pretty useful tool if you want to create a conveyor belt, because what you can do is you can create a single segment of your conveyor belt and then use the Mesh distribute node to create a line of those segments. And then if I take the geometry and apply CurveWarp to our curve, it'll wrap around that curve. But as you can see, there's a gap here. These two pieces don't interlock. The reason for that is that Mesh, well, the CurveWarp deformer will take the very beginning of your bounding box and the very end of your bounding box, and it will match those up to the beginning and end of the curve, because the curve starts here and comes around and ends here. So in order to have these two pieces overlap, what we would need is not just a curve that goes around in a circle once, but a curve that starts here, goes around, and then overlaps a little segment here. And that means that we can't have a closed curve. It's going to be an open curve. So this isn't a tutorial of how to build this whole node network. I'm just going to be stepping through the node network that I created to achieve that result. So to create a curve in the shape of our original curve that includes a little bit of overlap, we're going to be creating 4 curve segments and then attaching them all together. So to begin with, we have this curve segment in red. And so what this curve segment is it starts at whatever offset value we put into the rig, and it always ends where our original curve ends. We get this curve by taking our original guide curve, and I just use a rebuild curve node so that the parameterization of it goes from 0 to 1, which is easier to work with. And then I plug it into a subcurve node, so now we can take just a section of the curve. And the way that we get the min-max value, like I said, the max value should always be 1, because it's ending where the curve normally ends. But then the starting point, so we don't actually just take the offset value and directly plug it in as the min value. Because what if we take that offset and we need to rotate all the way around and go past 360 degrees? You can see that in our scene, it sort of snaps and it starts repeating the animation. The reason for that is that I have this anim curve set up, and let me show you what that looks like in the graph editor, that just remaps 0 to 0 and 1 to 1, but it's set to cycle. So if we were to go from 0 to 1 and then go a little bit past 1 to, let's say, 1.5, it would loop back around and give us the same value as if we had put in 0.5, which is exactly what we need to create that looping effect. There is one extra node that we need to achieve that effect, because the problem with just using this one node to create the looping is that if we were to put in a 1, we don't want 1 to return a value of 1. Because if you put in 1 and 1 here, it messes up the curve. So instead what we need to do is say, okay, do everything normally from 0 up to 0.99999, but then at 1, assume that it should be at 0. So it's like it's inclusive with this point, and it's exclusive with this point. So that condition node just does that. So whenever I give it a value of 1, it returns a 0, and if I give it something that isn't 1, it just passes it through without changing it. So that's the first segment explained. The second segment, I'll turn on here, which I have in green, just makes up the rest of the curve. So as you can see, the red plus the green always equals a full curve. So let's take a look at what we're doing to create that second one. So for our second segment, we have another subcurve node, and we take the min value of our original one. So where this one starts, this one is going to end, and this one is always going to start at 0, because it's always going to go from here to wherever our red one has been moved. So you can see that if I change that offset value. The red one always ends here, and the green one always starts there and meets back with where the red one begins. So you might be wondering what these offset curve nodes are for. That's just for some visual feedback. If I take some offset, I just added a little attribute here so that I can offset these curves away from each other so that they're not overlapping visually, but the actual rig would have these all set to 0. So let's take a look at the third segment of the curve. And here it is useful to use that offset. So what this third segment in light blue does is it goes from where the green curve, our second one, ends, and it continues around the length of whatever offset, whatever overlap value we put in. So you can see right now it goes around 0.5, but if I were to decrease that, it wouldn't go as far. So let's take a look at the node network that drives that. So as we can see, its min is the same as the max of our second curve, so it always starts where that one ends, and its max value is just that min value plus whatever our overlap is. So if we had offset by 0.25 and our overlap was 0.5, we would add those together and get a max value of 0.75 for where that ends. So that's the third curve explained. And it seems like that should be everything we need. We have 2 curves to give us the full loop around, and then we have an extra one for the offset. But the problem with just having 3 is that if I continue to move the offset around, eventually this endpoint plus whatever overlap we want goes through the endpoint of the curve. And we can't jump from the end to the beginning using one subcurve node. So instead, we have to have a 4th curve. So this 4th curve, it always starts at 0, and its max value is just the max value of our previous curve, but we subtract 1. So let's say we are here at, well, this is about 0.75, and then we add an overlap of 0.5, so that we would get to 1.25. What we do is we subtract 1 to just figure out how much we've gone past that full rotation of 1. And so we do that by subtracting 1, and then we have a condition node to guarantee that it will only give us a positive result. So if we were to have this have a lower offset where it doesn't quite go past 0, what would happen is we would take that value and subtract 1. We'd get a value that's less than 0, and instead of returning that, we'll return 0. And that just means that this curve won't exist because it goes from 0 to 0. So now that we have, let me rotate this so we can see all 4. all four curves that we need to create our full curve plus the overlap. Now we need to connect them all into one continuous curve. I'm going to pull up the node editor to show you how we're doing that. So it's pretty simple. So we would just take our first segment, plug it into an attach curve with our second segment. But we can't just loop together multiple attach curve nodes because there's a problem. Let's say that my offset were 0. So now this first curve, the red one, goes all the way around, and there is no green curve because we don't need it, because the start point and end point of our red one are 0 and 1. So that means this curve is invalid. If we were to just use an attach curve node, I can show you that this doesn't output anything. This curve that we get out has no min-max value, it's invalid. So to resolve that invalid curve issue, what we have to do is we have to detect when that second curve is invalid. So what we can do is use a condition node. And that condition node just looks at the max value of that subcurve. So if that max value is 0, then we know that this curve is invalid because it's running from 0 to 0. So we take that max value, we plug it into our condition node to say, is this 0 or is it something else? And then we use the output from that condition node to drive this choice node. And that choice node lets us select between the result of our attach curve and our original curve, because we know that our original first segment curve is always going to be valid. So if this curve happens to be valid, if this happens to be invalid, then this choice and condition node setup is going to sort of skip out on attaching this one and just give us our first curve instead. So we pass that resulting curve into our next attach curve node to try and attach the third segment. And so you'll see that we do have something slightly different. We don't have, we're not using the max value here. Instead, we're just using the number of spans on that curve. The reason that we have to do that is because there's sort of a strange behavior of the subcurve node that if you have a minimum and maximum of 1, it's actually considered a valid curve, that's the full length of the curve. But if you give it 0, 0, then it's invalid. So that's only an issue on this first curve. You could potentially run into a case where you're putting in 1, 1. But on this second curve, that's not the case, so we can just use the number of spans to determine whether or not it's valid. So we know that it's always going to have some number of spans if it is valid, and if it's invalid, it's going to tell us that it has 0 spans. So we can just use this condition node to check if the number of spans is 0, and if the number of spans are 0, then we'll just use our first segment curve and not attach this one. And if the number of spans is greater than 0, then we'll attach it and then take that attach curve result out through this choice node. So then we just do that same thing once more for our fourth segment, and then we can attach that to our CurveWarp deformer. So I'll show you what that looks like. So here we have our individual segment, and then let me turn off all of these offsets so our curves are actually overlapping properly. So here's our laid out curve, and I'll turn on the CurveWarp deformer, and you can see that those two pieces interlock now, because originally they were not interlocked, but now with this extra work that we did to create an overlapping curve, they interlock properly. You can see that when I change the offset value, it actually rotates around. So that's how you can create an interlocking conveyor belt rig using the CurveWarp deformer.